Namaskaram. Welcome to the Mana TV Telangana channel. Today we are going to discuss about the logarithms, so which is related to the mains for Gurukul. Okay, so now let us have a brief discussion on logarithms. See, first of all, so what is the logarithm? Suppose a to the power of x is equal to n. So what do we call this one? This is called exponential form. So as it is an exponential form, this is called base, this is actually exponent, this is power, a power x is equal to n. Now this x is called logarithm of n to the base a. So this can be written as x is equal to log n to the base a. So this is the first concept. So that means the exponent is nothing but the logarithm. Suppose if this x is being replaced by log n base a, what do you expect it? What shall you get? See, here we get a power log n to the base a equals to n. So now let us examine some examples. Here one example, 3 to the power of log phi base 3. So this is phi. Am I correct? So in the similar manner, suppose 2017 to the power of log x base 2017. So it is quite obvious, x itself only. So now let us study some properties of the logarithms. So properties of the logarithms. So what are the properties of logarithms here? See, log 1 to the base a is equal to 0. Okay. Next, log a to the base a is equal to 1. Okay. Next, log x to the power of n to the base a. This is, in general, this is called power rule. So this can be written n multiplied by log x base a. So now let us see some more results. Suppose log x to the power of alpha base a to the power of beta. So what will be this one? So this is equal to alpha by beta log x to the base a. Okay. Now one more, log a base c multiplied by log c to the base b. What is the value of this one? Now in general this is called change of base rule. So this is can be written as log a to the base b. Again, this sometimes this log a to the base b also can be written as log a by log b. Here base says something x. This x is known as valid base. This x is valid base. Now let us discuss properties on the logarithms. So log of ab to the base x. So that means product of the two numbers. When you apply the logarithm to the product of the two numbers, what do we get? Here we get log a to the base x plus log b to the base x. Its converse is also true. That means whenever log a to the base x plus log b to the base x is there, that can be written as a single logarithm. Single logarithm means log ab to the base x. Okay. Now log of a by b to the base x. So, you can expect. So, this can be written as log a to the base x minus log b to the base x. So, now if you want to write this log a to the base x minus log b to the base x as a single logarithm, so that can be written log of a by b to the base x. Okay. Now, so let us see the nature of the base of the logarithmic function. Suppose we have discussed a power x is equal to n, that implies x is equal to log n to the base a. Here, see, n must be greater than 0, positive number, and this base a must be greater than 0 or 0 less than a less than 1. So, these conditions are to be followed to define a logarithmic function from exponential function to logarithmic functions. That means, logarithmic functions are defined to the positive numbers only. Okay? So, now, let us discuss about how to apply the concept of inequality over logarithms. So, suppose here base is a greater than 0, okay, and x greater than y. Suppose if you want to apply logarithm on both sides here, what will happen? Let us see. That implies we get log x to the base a greater than log y to the base a. Here inequality symbol does not change, it remains as it is. Suppose instead of a greater than 0, here 0 less than a less than 1 is there, provided here x greater than y. If you want to apply logarithm on both sides, so what shall we get? Let us see. Here log x to the base a less than log y to the base is very, very important. So, in this case it is an increasing function, whereas in this case it is a decreasing function. Okay. Now, we shall do some problems on the logarithms. So, let us note down the first problem. Log 1728 base 12 is equal to, first option 1, 2, 3, 4. So, do you expect the answer? Okay. Here see 1728. 1728 is the 12 cubed. 12 into 12 into 12, we get 1728. So, this problem can be solved like this. 1728 is equal to 12 cube. So, here log 12 cube base 12 using power rule. So, this can be solved 3 multiplied by log 12 base 12. Do you expect what is log 12 base 12? Yes, log 12 base 12 is in the form of log a to the base a. So, it is 1, we get 3 times 1. So, 3, which is the right option. Yes, the C will be the right option. Let us move to the second question. Log x to the power of 4 base y here y cube multiplied by log y power 4 z cube base z cube multiplied by log z power 4 to the base x cube equals to. So, let us write the options. So, first option 4 by 3, 3 by 4, 64 by 27, D 27 by 64. The problem appears to be typical, but it is very easy. Just if you go through one of the formulae which we have studied earlier. So, what is the formula here? Here see, you remember this formula, log a to the power of alpha to the base b to the power of beta, which equals to alpha by beta log a to the base b. Just if you apply this formula, this problem can be cracked very easy manner. See, this can be written 4 by 3, 4 by 3, 4 by 3. So, that means 4 by 3 times this is 4 by 3 and multiplied by 4 by 3, here log x to the base y, this is log y to the base z into log z to the base x. Here see, so now apply the change of base rule. This becomes log x base y log y to the base z is nothing but this is log x to the base z. If you multiply for this one, log x base z multiplied by log z base x, you get 1. So, that means total this becomes 1. So, this equal to 4 into 4 16 into 4 64 by 3 into 3 9 into 3 27 into 1. So, 64 by 27, which is the right option? Yes, C will be the right option. Shall we move to the next problem? So, third one, 1 by 1 plus log BC to the base A plus 1 by 1 plus log CA to the base B plus 1 by 1 plus log AB to the base C is equal to. So, now option A 0, option 2 1, option 3 ABC, option 4 A plus B plus C. Okay. So, now how to do this problem? So, using the properties of logarithms only, the using formulae of logarithms only. Here 1 can be written as base A, here 1 can be written as base B, here C can be written as base C. So, that means now this can be written simply shortly also sigma 1 by 1 plus log BC to the base A. For our convenience, I have written sigma because so all the terms are being in cyclic order, so that I have written sigma notation here. Do not worry. So, now here this is sigma 1 by the 1 can be replaced by log A base A, which is equal to 1. So, this is log A to the base A plus log BC to the base A. So, we have already discussed here. So, log A plus log B, that can be put in a single logarithm. So, this equals to sigma 1 by log of ABC to the base A. So, this can be written sigma log A to the base ABC. Now, this can be rewritten as log A to the base ABC, okay, plus log B to the base ABC plus log C to the base ABC. So, let us think, can we write as a single logarithm? So, why not? We can write this one as a single logarithm. So, now as base ABC. So, now this is log of A into B into C log ABC to the base ABC. Now, you can expect answer 1. Second option is the right option. So, now let us go for another problem. Log of tan of 0.25 pi to the base 5. Here A 0 to 1, okay. Third one pi, sorry, this is B, this is C option, D option. So, that will be pi by 4, okay. So, now how shall we do this problem? So, let us think for a while. Here log of tan of 0.25 pi to the base 5. So, what is 0.25? So, 0.25 can be converted into a fraction form, that is 25 by 100 we know. 25 by 100 is nothing but what is the simplest form, that is 1 by 4. So, 1 by 4 multiplied by 5 by 4 pi, that is pi by 4, that means 45 degrees. So, now this can be written as log of tan of 1 by 4 multiplied by pi, pi by 4 base 5. Tan 45 degrees from trigonometry, that is nothing but 1. So, this is equal to logarithm of 1 to the base 5. What is the answer? Yes, answer is 0. So, first option. Okay, now if x is equal to root 2 plus root 2 plus root 2 plus dash dash infinity, that means infinity terms, then log of x by 2 is equal to. So, let us verify the options now. A 0, B 1, C 2, D 3. So, generally, these kind of problems appears in the examination, generally we get tension, okay, because here root of 2 plus up to infinity is there, and once again log of x by 2 is asked. So, that means actually here it is very simple, root of 2 plus root of 2 plus root of 2 dash dash infinity is there. First we have to find out the value of x. So, having been evaluated the value of x, after that replace here, the base may be here 10 or whatever it may be base here, valid base. So, we get the answer. So, that means first let us concentrate on how to evaluate the value of x. So, now I will give the very simple technique for this one to find out in the examinations also. Here 2 or maybe 6 or 42 or 12 may be given. The 2 can be written as the product of two consecutive integers. The 2 can be only one way we can write it, that is 2 into 1. Of all these two factors, which will be the maximum? 2. So, this answer also x becomes 2. So, that means here x is equal to 2. I give the hint also. This 2 can be written as 2 into 1. The 2 will be the answer. So, x is equal to 2. Now, what we have to find out here? Log of x by 2, which is equal to log 1. So, that is 0. So, option is A. So, next problem. Okay. Sixth one. 2 to the power of log 5 to the base 3 minus 5 to the power of log 2 base 3 equals to A 0, B 1, C log 5 base 3, D so 2. So, this problem actually seems to be typical, but it is based on one simple concept, that is we can generalize this problem also. So, one of the generalizations we can remember, using that generalizations. So, these kind of problems simply we can write in the examinations, because it is a competitive entrance examination, we do not have the enough time, much time to crack the problem. So, we have to remember some generalizations. So, I will give the one generalization here. So, I need not explain the lengthy method or tedious method here. So, let us have a generalization here. So, what is the generalization? So, you better remember this one, a to the power of log b minus b to the power of log a. Here see, very carefully observe here, a to the power of log b and again b to the power of log a, always 0. Here base must be common, here base see 3 common. Now, according to this generalization, 2 to the power of log 5 minus 5 to the power of log 2 obviously becomes 0 itself only. So, the first option is the right option. Okay. If log of x square plus x base 4 minus log of x plus 1 to the base 4 equal to 2, then x is equal to, okay. Here A 2, option B 4, option C 8, option D 16. So, now logarithms are actually connected to the here algebra linear equations. So, first read the problem here. What is the problem we have? Just if you say x square plus x is a, x plus 1 is equal to b, this is in the form of log a minus log b. So, that can be put as a single logarithm. First let us put as a single logarithm, after that easily we can solve it. So, now being put as a single logarithm, this can be written as log of x square plus x over x plus 1 to the base 4 is equal to 2. Now, just simplification has to be done here. Log of, so x is taken out, x into x plus 1 by x plus 1 to the base 4 is equal to 2. Here see x plus 1 gets cancelled. So, we have here log x to the base 4 is equal to 2. Here we have to change logarithmic form into the exponential form. So, that will be our answer. So, here x is equal to 4 raised to 2, 4 square, we know 16. So, which is the right option? Yes, D will be the right option. So, next problem, a is equal to log 27 to the base 12, then log 2 base 3 is equal to, first option or option A 2 minus a by 3a. So, third option, sorry, B, option B 3 minus a by 2a, option C 3 plus a by 2a, option D 2 plus a by 2a. So, that means in this problem, so let us have some discussion. Log 27 to the base 2 is given in terms of a, and we are asked to find out the value of log 2 base 3 in terms of a only. So, that means the first of all let us simplify this log 27 to the base 12 in terms of 2 and 3, so that we get the value of log 2 base 3. Okay, shall we do the problem? Okay, let us do it. Here a is equal to, this 27 can be written as 3 cube, okay, 3 cube, base 2 write down, or base 3 no problem, anything we can write it, base 2. This is 12, we can write 2 square into 3, 4 into 3 12. So, that means if you apply log 12, this will be 2 log 2 base 3 plus log 3 base 3 is 1. This is 3 into 3 times log 3 base 2, sorry, this will be, wait, applying for base 2 log 12 base 2, this is 2 plus log 3 base 2, this is 2 plus log 3 base 2. Okay. Now, this is 3 times log 3 base 2 by 2 plus log 3 base 2. Just cross multiply. If you cross multiply, what do you get? You see, okay, 2a a into log 3 base 2 is equal to 3 log 3 base 2. Okay. So, what is our aim? To find out log 2 base 3. Now, this can be written 3 log 3 base 2 minus a log 3 base 2 is equal to 2a. Now, this log 3 base 2 common, we get 3 minus a. So, this is 2a by 3 minus a. But what do we require? Log 2 base 3, that is the reciprocal of this one. So, 3 minus a by 2a. So, which is the right option? B will be the right option. Okay, next problem let us do. Log of x plus y by 3 equals to of log x plus log y. Then x by y plus y by x is equal to. So, A 7, B 9, C 2, D 3. Okay. This is very important problem. So, you might have seen in our test book, 10th class test book, real numbers. This problem is given, log of x plus y by 3 is equal to of into log x plus log y. So, how to do these kind of problems? So, these kind of problems can be done using one shortcut formula. I will give the shortcut formula. So, note down, better remember the shortcut formula. Log of x plus y by n. So, n may be any number here, 3 or like 5 or 7 like that. This is equal to of times log x plus log y. So, then x by y plus y by x is equal to, here very important. So, better to notice this shortcut, you have to remember, that is n square minus 2, that is all, very simple. So, instead of doing very lengthy method, you can remember. So, what is the n value here? Here n value is 3. So, let us substitute. So, therefore, here our answer becomes x by y plus y by x is equal to, this is equal to, n is 3. So, n square, 3 square, here minus 2. See, let us check it, 9 minus 2, 7. So, you get the answer 7. Which is the right option? A will be the right option. Okay, now, so let us do the next problem. Okay. Now, next problem, log x by 2 is equal to log y by 3 is equal to log z by 5. Then x power 4 equals to a y z, b x y, c z x, d x plus y plus z. Okay. So, how to solve this problem? Let us see. Log x by 2 is equal to log y by 3 is equal to log z by 5. Then x to the power of 4 in terms of y z, in terms of x and y, or in terms of z x, or in terms of x y z, we have to find the value. Here first let us assume this log x over 2, log y over 3, log z over 5, something k, where k does not equal to 0 provided. Now, log x becomes 2k. Suppose this is a common logarithm whose base is 10. So, x can be written 10 power 2k. In the similar fashion, log y is equal to 3k. Now, y you can write 10 power 3k. So, in the similar manner, z is equal to 10 power 5k. Okay. Now, we have to establish relation between these three. So, how shall we establish? That is the question mark here. So, let us establish the relation. So, if you multiply these two, let us see what do you get. Otherwise, you can do one thing. Here already x to the power of 4 is there. X to the power of 4 means x raised to 4 on both sides. This becomes 10 power 8k. Am I correct? This 10 power 8k can be written as 10 power 5k multiplied by 10 power 3k. Just check it. So, this is nothing but y, this is nothing but y. Sorry, this is nothing but z, this is nothing but y. So, y into z, y z. So, which is the right option here? Yes, A will be the right option. Okay, next question. If 5.7 power x is equal to 0.57 power y is equal to 1000, then 1 by x minus 1 by y equals to, see, A 3, B 1 by 3, C 1 by 4, D 1 by 5. So, this is also one of the important questions, but using logarithms also this problem can be solved, or using indices, theory of indices also the problem can be solved, but that will be the lengthy method. So, in order to avoid lengthy method, so this problem can be remembered in easy manner. So, let me explain that shortcut. So, what is the shortcut behind this problem is, here just go through the 5.7 volt to the power of x is equal to 0.57 volt to the power of y is equal to, this will be 10,000, always number of zeros will be given here. So, now here you remember this problem as like this, 1 by x minus 1 by y equals to, here write down first of all, divided here, numerator and denominator you have to write. So, what is the numerator means? First you count number of decimal places here, 1, 2, 2, put minus sign. How many decimal places here? 1, 2 minus 1. Here how many number of zeros are there? Very easy to count, 3, by 3 write down. So, answer is 1 by 3. The problems which are in the form of this one, all the problems can be solved using this shortcut, but sometimes in the examination the question may be given in reverse order. When it is given in reverse order, suppose instead of 1 by x minus 1 by y, 1 by y minus 1 by x is given, just you have to change the sign, that becomes minus 1 by 3, that you have to keep in mind. Okay. So, now which is the right option in this one? Yes, B is the right option. Log of x minus 1 to the base 0.3 less than log of x minus 1 to the base 0.09. Then the interval in which x lies in C A closed 1 comma 2, B 2 to infinity, C this is r minus 1 comma 2, sorry this is r minus 1 comma 2, D r minus closed 1 comma 2. See, you might be familiar with the different types of the intervals. So, at this juncture I need not explain about the intervals, the better go to the calculus chapter. While introducing the calculus chapter limits, so you might have discussed all this about the intervals. Okay. So, let us do the problem now. Okay. If you want to solve this problem, here this is log of x minus 1 to the base 0.3 less than log of x minus 1, this 0.09 we can write 0.3 whole square. Okay. Now, this can be written log of x minus 1 to the base 0.3 less than. So, using the formula, already we have discussed this formula, log a to the power of alpha to the base b to the power of beta. alpha by beta log A to the base B. Okay. Using that formula, this can be written as 1 by 2 log of x minus 1 to the base 0.3. Multiply 2 on both sides. So, this can be written 2 log of x minus 1 to the base 0.3 less than log of x minus 1 to the base 0.3. Okay. Again, here this can be written as log of x minus 1 whole square 0.3 less than log of x minus 1 base 0.3. Just concentrate on the base. Here base is lies between 0 and 1. Whenever it is 0 and 1, so this can be written now as x minus 1 whole square greater than x minus 1. Just you simplify it. X square minus 2x plus 1 greater than x minus 1. If you simplify, x square minus 3x plus 2 greater than 0. So, we have to solve this quadratic inequation. We know these factors are x minus 1 into x minus 2. That means x does not lie between 1 and 2. X does not lie between 1 and 2 means here either is x less than 1 or x greater than 2, or this can be rewritten as r minus closed 1 comma 2. So, D will be the right option. Okay. Next one, if 1 less than a less than or equal to x, then the minimum value of log x to the base a plus log a to the base x is. So, now 2 b 3 c 4 d 5. Okay. So, the being actually this is the competitive entrance examination. So, these kind of questions may be asked in examination also, but it is very simple concept. So, this based on inequality concept, that is arithmetic geometric inequality. So, that is nothing but, first suppose let a comma b are two positive real numbers, then a plus b by 2 is greater than or equal to root a b. Using that concept, this problem can be solved. Suppose here you see let p is equal to log x to the base a, q is equal to log a to the base x. So, now we can write p plus q by 2 is greater than or equal to root pq. So, this is arithmetic mean is greater than or equal to geometric mean using this inequality. P plus q means log x to the base a plus log a to the base x greater than or equal to 2 root of p into q. If you multiply these two, what do you get it? That is log x by log a by log x. Cancel, you get 1. So, that is greater than or equal to 2. That means, the log x base a plus log a to the base x take the values from 2 to infinity. So, which will be the minimum? It is obvious, 2 will be the minimum value. So, A will be the right option. Okay. If of times log of 11 plus 4 root 7 to the base 10 equals to log of 2 plus x to the base 10, then x is equal to a 1, b root 2, c root 7, d root 8. Okay. So, now here hint, this becomes root of this one, is equal to log of 2 plus x to the base 10. So, if you compare both sides, what do you get now here? 2 plus x is the square root of this one. So, we can write 2 plus x is equal to root of 11 plus 2 root of this can be written 28. This 28 can be written as 7 into 4. This will be root 7 plus root 4, 2 plus root 7. Comparing on both sides, x is equal to root 7. This is the right answer.